This video is about application of De Moivre's theorem, solving complex equations. When you solve z to the nth power equals a, you need to change this a into Euler form or polar form. I prefer to change it into Euler form, e times e to the power of I theta. Then there are n roots. Z sub k equals nth root of r cis theta plus 2k pi over n, or nth root of r times e to the power of I times theta plus 2k pi over n. This k equals 0, 1, 2 until n minus 1. The argument for each root, theta sub k equals theta plus 2k pi over n. The roots z sub k are points on a circle centered at the origin with the radius nth root of r. In other words, all the roots are spaced equally around the circle and form a regular n-gon inscribed in the circle. The first root, z sub 0, has an argument theta over n. Each subsequent root is obtained by rotating counterclockwise by 2 pi over n. The roots are symmetric about the origin. The difference between any two n times theta sub k are multiple of 2. For example, for this equilateral triangle will be the roots of z to the third power equals a. The angle between two subsequent roots is 2 pi over n, which is 2 pi over 3, which is 120 degrees. Let's go to this inscribed square. All the points are the roots of z to the fourth power equals a. The angle between two subsequent roots will be 90 degrees. All the points on this regular polygon will be the root of z to the fifth power equals a. The angle between two subsequent roots will be 2 pi over 5, which is 360 divided by 5 equals 72 degrees. All the points on this circle will be the roots for z to the eighth power equals a. The angle between two subsequent roots will be 45 degrees, which is pi over 4. Let's go to guided practice 1. Solve z squared equals -1 minus I square root of 3. Give your answer in the form of r e to the power I theta, where r theta are real numbers. R is positive. Z squared equals -1 minus I square root of 3. First step, we need to change -1 minus I square root of 3 into Euler form. R equals square root -1 squared plus square root of 3 squared equals 2. So, -1 minus I square root of 3 equals, take a 2 out, -1 over 2 minus I square root of 3 over 2. Let's go to Argand diagram. In your mind, always remember two special triangles. This is a 30 degree. Then corresponding side will be 1/2. This is a 60 degree. Corresponding side is a square root of 3 over 2. This is 1. For this isosceles right triangle, label square root of 2 over 2, square root of 2 over 2. This is 1. As we know, square root of 3 over 2 greater than 1 over 2. In other words, square root of 3 over 2, the corresponding angle is 60, which is pi over 3. 1/2 its corresponding angle is 30 degree, which is pi over 6. Remember, the imaginary part of complex numbers decides the reference angle. Square root of 3 over 2, its reference angle is 60 degree, which is pi over 3. This is x, this is y. -1/2. Then negative square root of 3 over 2. Remember, reference angle will be formed by x-axis. Complex number is located on the third quadrant. Theta equals 4 pi over 3. Therefore, we have 2 times e to the power of I times 4 pi over 3. Z squared equals 2 times e to the power of I times 4 pi over 3. Then z equals 2 times e to the power of I times 4 pi over 3 plus 2k pi, then to the power of 1/2 equals 2 to the power of 1/2 is the square root of 2. Power of power, we will do the multiplication. So e to the power of I times 4 pi over 3 plus 2k pi combined together times 3 over 3. So we get 4 pi plus 6k pi over 3. Then times 1/2, we will get 4 pi plus 6k pi over 6. Then 1k equals 0. Z 0 equals square root of 2 e to the power of I times 2 pi over 3. K equals 1. Z1 equals square root of 2 e to the power of I times 4 pi plus 6 pi over 6. Reduce square root of 2 e to the power of I 10 pi over 6, which is 5 pi over 3. So we got two solutions. Let's go to B. We need to change this into A plus IB form. Z0 equals square root of 2 e to the power of 2 pi over 3I. Let's sketch the graph. 2 pi over 3 go to second quadrant. Reference angle is pi over 3, 60. 60 is away from x-axis. Now label. Corresponding side of 60 degree is square root of 3 over 2. This is negative 1/2. So we get square root of 2 times x plus yi, which is negative 1/2, plus square root of 3 over 2i. Negative square root of 2 over 2 plus square root of 6 over 2i. For z1 equals square root of 2 e to the power of I times 5 pi over 3. 5 pi over 3 is in the fourth quadrant. Reference angle is pi over 3. So away from this x-axis. This is 60 degree. Corresponding size is negative square root of 3 over 2. This is 1/2. So we get square root of 2 times 1/2 minus square root of 3 over 2i. Square root of 2 over 2 minus square root of 6 over 2i.